What's up guys, and welcome to this interesting video. In this video we're going to talk about the house price prediction project, and we'll be dealing with in-depth and we'll be making end-to-end machine learning project which is based upon real estate market application. You can follow this project and complete this project and put on your resume. That will look absolutely great, that in case you are a beginner, because a beginner project should be that you will be dealing, you will be very happy to see that you had done your first project. And the prerequisites of this project is that you should know at least my previous videos, that topics that I have taught. Be sure to check it out. In case you haven't seen that, I recommend you to first access that playlist and watch all the videos in case you don't know about the machine learning. Okay, so I will be giving in the link description box below, so be sure to check it out. Now let's come back to our topic, which is what we'll be dealing. We'll be dealing with an end-to-end machine learning project, which is house price prediction in Watson with the Watson dataset. Okay, now we will not deploy it, but we'll save it. That will be ready for deployment. Deployment series will be coming soon, so don't worry about it. Will not the deployment means, it simply means that we have to give a side of the website that anyone can put a number in that and will predict that. Okay, not that, but we'll be building an end-to-end machine learning project and we'll save our model so that we can deploy it. Okay, now let's see some of the details of the project and the basic thing that you have to ask to your boss or understand the problem. That let's assume that you got your first project, and the first thing that you have to do, understand your problem. Understanding problem is the key that you have to deal with. That in this problem we will be dealing with the Watson dataset, okay, and we have to predict the price of the house based on the multiple number of inputs, and this is the multivariate linear regression project. Okay, in the real world you will be not getting a univariate linear regression, you will be most commonly getting a multivariate linear regression. Okay, so it's a multivariate linear regression project. However, linear regression is not a very good approach, but it's a good approach to solve this problem, as there are more algorithms would be more suitable, but we have understand till now, so we'll be using our linear regression, and then in further we'll improve our model. So first, then in the second, it is a supervised learning problem, and it is also a regression problem, so we'll be using the linear regression. Now we'll be using our linear regression. Now the understanding of basic workflow for a machine learning project. First, we'll gather our data. That simply means that we have to take our data, that means from any source, and then what we have to do, we have to pre-process our data before feeding to the algorithm. Then what we'll do, research the model that will be best fit for the type of the data. In this data we have multiple columns, and in case of multiple columns, our multivariate linear regression will be the best fit. Training and testing the model. We'll train the model and test the model. We will evaluate it. What do you mean by evaluation? It simply means that you have to check the accuracy of your model using our mean square error or cost function that I have talked about in my previous videos. And at last but not the least, we will save our model that will be ready for deployment. Okay, now what you will learn in this project, you will implement all you have learned from my previous videos, and you will learn basic workflow machine learning project. You will work with the data. This is the main. You will work with the data. You will learn to implement linear regression, not from very scratch. We have done in our previous videos. We will do this with the help of a scikit-learn library, which is the so-called library for machine learning in Python. Then we have, after this project, you will have a good understanding of linear regression, and you will learn how to approach the machine learning project or a problem. And at last but not the least, you will build your first resume project as a machine learner, and you will be putting on your GitHub profile or on your website so that you can show up to your clients, etc., or your friends. Now that's it for the details of this project. Now it's time to do the coding part and make our end-to-end machine learning project of the real estate market application. So let's do the coding part. So I am on my Jupyter notebook. So here we have the title, Boston Price Prediction Using Linear Regression, which is the application of real estate. So before going on to the coding part, let's first take the look at the installation part of the Jupyter notebooks and the Anaconda. So first of all, the Jupyter notebook can be found at go on Google and write Anaconda download and just click on individual edition. And if you click onto that, just go click on the download button and it will redirect you to Atlas. And if you are on Mac, you can use the Mac version, whatever your bit is. If you are on a Linux, you can use this. And if you are on Windows, you can use this, whatever your 64-bit or 32-bit. And in case you don't know how to check your 64-bit or 32-bit, just go here at your, and just go to this PC and properties, and you will see here 64-bit operating system times 64-bit processor. Here you can find the 64-bit operating system. Okay, I think that will be suitable for you all, and you can download it from here. And in case you don't want to download just now and you want to follow up me with my course, just go on Google and write Google Collab, and this will give you the same the Jupyter notebook style. You can go there and click on that, and what the thing is that Boston Price Prediction, and you will be getting this one. Okay, now I have opened the same notebook that I opened here on the same here. Now what you can do, you can go here and click on File, New Notebook, and wait for some time, and what it will do. So it opened. Now just click on Connect here. You can see Connect, and it is allocating. It takes some time. So it is connected. Now you can see there it is the green tick. Now what you can do, you can name it as whatever you want. Boston, let's see, the housing, and just click on OK. Now what it just to see here is that first print. You can also do whatever I'm doing here. Just do here and you will get the same outputs, the same. Okay, and in case you want Jupyter notebook, you can also do this. And how to run this, you can click on run here, or you can press shift enter and it will run the thing. Okay, now you can follow this one also and this one also. I'll be using Jupyter notebook. Okay, now first of all, what is that we have to gather our data? It means we have to bring our data. So first of all, let's import all the libraries. It's always a good practice to import the important libraries. Okay, import all the libraries. Okay, so first of all, you have to import numpy as np, and just wait for some time. Yeah, import numpy as np, just some more time. Okay, now then we have to import pandas, and I also hope that you might something familiar with Python. Okay, and it's pandas and numpy library, and import pandas, import matplotlib cborn as SNS, and then we have our sklearn matrices, sklearn from sklearn dot matrix, import mean squared error. You can import that mean squared error. Okay, now we have this one, and again what you can do, you can also import the matplotlib dot pyplot as plt. Okay, now just click shift enter and it will run. Okay, and one more thing you can do, you can just write matplotlib in line, matplotlib dot in line. Just run this. Okay, Now explaining you step by step. What is NumPy used for? NumPy is used for mathematical computation. You will see here the scientific calculation or mathematical, so you will write it as computations. And then we have our favorite pandas, which is a very important library for working with the data, and then we have a Seaborn for visualizing things, and then we have a mean square error. We don't have to implement our cast function from very scratch. There is a library called scikit-learn which will help us to do this without doing any kind of writing equation, so we can import that without wasting our time. So for cost function, you can write it here for checking our accuracy. Then we have also visualizing things, and this is only for Jupyter notebooks. So don't do this on your Collab. Okay, so just run this and then okay. Now we have imported all the important libraries. Further libraries will be imported as per our need. So now what is the time is that we have to data preprocess. It means we have to, the data gathering. What we have to do, we have to bring our data. So first of all, let's import all the data sets from itself in scikit-learn. There is a data set which is a Boston data set, and from that data set we have to import a data set called Boston. So dot datasets import we have to import the load Boston. Okay, now what we can do, we can just make a variable and just instantiate it, load Boston. Okay, now we have this data Boston, but if you do this onto it will print something like that. And what is this? It is the data. It is only the data. We have to convert it into our data frame. So let's convert it into our data frame. So first of all, data equals to the Boston dot data. Okay, Boston dot data, and then what we can do, we can print out data here, and okay. So we have, now it's time for the converting our Boston into a data frame. So pd dot data frame Boston dot data. Now if I run this, it will print something like that, and this is in our data frame. Now it's time for making, and you can see here our column names is something like that, 0 1 2 3, and we don't want this. So what we can do, we can simply write the data again, data equals, so we have to change the column name. So data equals to data dot columns equals to our Boston dot feature names. Okay, now if we take a look at the data points, 5 data points, and it will the CRIM, JN, enters, and you will see here is that, and you will be asking me that what is this CRIM, JN, enters, chas, and it's also always a good practice to know or to get familiar with your data set. So if I'm going to explain you all of this, it will gain a lot of time. Just a quick recapitulation. Let me write one thing here. So I have written down some of the key points for this. So what is cream here? Cream is the rate by town, capita. Then we have JN. You can read these all are in the simple English format. You will get familiar with that. I have already gotten familiar with that. So here you can read it out and just get familiar with that. I have just written for you all, and you will be getting this Jupyter notebook in the description box below, and all the important notes will be given in the description box below. Okay, now what is the time is that we have to, there is not any kind of target variable. So what we can do, the target variable is that on the basis of these all inputs we have to predict the price, but the price column is not there. So let's make our price column data data price price, and what we can do, so just make this spelling clear, price, and what the price would be, the Boston, we have our data set that we have data dot target, the target here, and then what we can do, data dot head, we will take a look at the data head, and what is this, we have again the price at last. Okay, and I think this is all the working with the data, gathering data is now clear to you. First, what we have done, we have load our data, then what we have converted into data frame, and then we had changed the columns with the feature name of the Boston, and then I have written some of the key points for columns, what the column is doing actually, and then we have made a target variable which is a price dot head. Okay, now what is the time? So let's do this so that you can clearly see that. So now it's time for data preprocessing. So first of all, let's take a look at data dot shape. Okay, the data dot shape, it simply means that we have a 506 rows and a 14 columns. What we can do, we can take a look at a data dot columns, data dot columns, columns, and you will get a take a look at the data columns. And also what you can do is that data dot d types, you can take a look at the type of our data, and the type of our data is all floating point number. Okay, now it's time for checking any null values or missing values. So data dot is null dot sum, it will sum it all up and it will give it a is null, else should be, yeah. Okay, now there is not any kind of null values in that, so we don't have to worry about that. And if our column is 80 features, we have 90 features, 100 features, so it's a very tough thing to remember. There is not any kind of null values in our columns. In case you can do this, data dot is null that any and in the axis equals to 1. Sorry, it should name as axis, and again s. Okay, now let's run this, and we have nothing kind of our null values in that. Now it's time for checking some of the information about the data. So first of all, now what you can do, data dot describe, it will describe our data and it will present our mean, standard deviation, minimum, 25%, 50% maximum, etc. And also there is a data dot info which will give you that there is a null values, all about the information for your data. You can do this, that there are 506 entries, it means there are rows, and we have a columns here 0 to 13, and it has that number of rows with a non-null, and a DD type is this. You can do directly .info and you'll get all the information about the data. Now we'll take a look at the correlation. So, and in case you don't know about the correlation, be sure to search on internet, and then you will get this, all those kind of correlation. And then we have, let's print our correlation, and this will print this. And let's say the shape I think should be 14 by 14. Yeah, 14 by 14. Now let's plot it and visualize the plt dot figure fig size, then we have 20 comma 20. Now it's a heat map. Now what we'll do, we will plot a heat map plotting correlation, and what you can see here that we have plotted. Now let's do more thing here. C bar equals to true, square equals to true, square, then we have a square equals to true. Before going on to anot, we can also give the FMT here, FMT, the 0.1f, and then what we can do, we can give anot equals to true, and then what we can do, anot KWS for the size, so it would be the 15, size 15, and then the C map would be any kind of reds, it's good, or whatever you want to do, you can do this. Okay, so you can get a better intuition about the correlation for a data set here. Also, if you don't want to show this kind of texture, you can write plt dot show. Now the nothing will be shown as a texture. Now it's time for the main thing, that is training and testing the model. We have explored our dataset as much as we can. Now it's time for training and testing our dataset. So first of all, let's divide our dataset into x and y. Okay, so first of all, let's x equals to data dot drop the price, because we don't want price. Okay, now so we have studied that in case of our multivariate linear regression, we have multiple inputs, and based on our inputs we have to predict whatever the price of the house. What you can do, let's say we have our multivariate linear regression model, theta 0 plus theta 1 times x1 plus theta 2 times x2. Okay, and here what we can do, we can just initialize our theta 0, theta 1. These are the coefficient of our x's, and then we'll just let's say we have a theta 1, 2 and times x1 plus, and we have to give the input and we're going to get the output. Okay, so I think this all are clear cut for you all. Now let's recapitulate all those things that we have studied till now. So let's recapitulate. First of all, we had dealt with imported all the libraries here. Then we have load the data set, and then what we have done, we had the data frame of the Boston data. Then for the columns we have done that, and then it is all the columns, kind of the information about the columns, and then we had the price, which is the target. Then we have to data price equals to the Boston target that we have to predict, and we had taken a data preprocessing, that data dot shape, it means 5 and 6 rows and 14 columns, and then we have data dot columns, all the columns. Then we have taken a look at the data types, and all the data types in this are the floating point number. Then also we have taken a look at that there is any null values or not, and I will be explaining you a little bit more about this. So what is this? Here what we had done, we had taken a look at, is there any missing values or not, okay, and this was the main motive for doing this. And then again, what we had done here is that we had taken a look. You will see the data set that we had that will have 100 features, 200 features, etc., etc. And in that case you have to check that there is nothing to worry about the data, about the columns of the data, so that there would be any null values or not. Okay, so you can do this. Now we will take a look at data describe. It describes how you can also get the information about the data here, the mean, standard deviation, minimum, maximum, etc. And then and the short trick is that we will deal with the information for the data without doing all those kind of stuffs. Will non-null values, float, then we have columns, we have 5 and 6 rows, etc., etc. And the memory usage is 55.5 KB. Okay, then at last we had taken a look at the correlation, data.correlation. There is a method for this, and then we'll take a look at the shape, and then we have plotted our heat map with all this kind of attributes, and then we have shown that. Now you can also take the information from this here. Okay, and the last process is that we had x and y's, where x, we have categorized our data into x and y, and we have dropped our price so that it becomes x and the y would be the price. Okay, then we had imported our train test split and split our data into x's and y's, and the test side would be the 30%, and then we have random state equals to 3, so that our value or the test or data size could not be changed over and over. Then we have imported our linear regression, so that we don't have to do this from very scratch, because we have already gained intuition behind linear regression. So we have imported our scalar.linear model, we have linear regression, and then we have instantiated. Let me write instantiated in initialization, and then we fit it and or train the model, and then we are good to go, and we are trained the model. Now it's time to take a look at the coefficients of our theta 0, theta 1 of our multivariate. So first of all, COEFF, then we have our let's do this in our data frame. Let's plot this on our data frame. So data frame, not plot it, just frame this out in our data frame so that we get a better intuition about that. And then we have our xtrain dot columns, and then we have lm dot coefficient. The coefficient should look something like that. And what we have to do, just explaining you why I had done t here. Why I had done t? Well, because our coefficient would be something like that. Would be something 1, 2, 3, 4, and we have to stack them something like that. And for this we have to use dot transpose. That I had given intuition about the transpose also in my mathematics for machine learning video. So be sure to check it out in case you haven't. I'll be leaving a link in the description box below. Now what we can do, we can simply print our coefficient, and then now we have in 0 we have all the attributes, and in 1 we have our coefficients for our attributes. Now I think that you had gained intuition about all those things. Now it's time for the predictions. So what are you gonna do? Just make a variable where we'll store our, and we have a model lm where we'll do dot predict. There's a method for this for our linear regression class, and then element dot predict xtrain. Okay, now we are done with that. Now it's time for checking the accuracy of our model, how well our model perform on our xtrain. So print using there are more and more kind of the check for the functions that is used for checking the accuracy. For example, R2 square, RMSE, and MAE, which is mean absolute error, and etc. But till now we had learned only about the mean square error, so we'll be dealing with only this. Okay, nothing from outside. Now what we can do, matrix, not matrix, it should be we have already imported our mean squared, so we'll do this, and then it takes y train, and then the predicted value, which is y pred. Okay, now let's run this, and our mean squared error is 22.41971, etc. And then we'll take a look at y, the prediction on test pred equals to the lm dot predict ed and ict. Then we have x test. Okay, x test. Now run this. Okay, now let's check the accuracy so that it will give intuition about how well our model perform on both the thing, mean squared error. Then we have mean squared error. Then what you can do, y test prediction. Okay, now let's run this, and you can see here is that both are same, both are equal, means something equal, not approximately equal. So we can say our model best perform, but not as good as it is. So there are also many algorithms which will perform better than this, but it's all okay that it doesn't overfit. Okay, so don't worry about it. The overfitting terms, we'll get into it in the later. Just understand that we got both the values same. Okay, so now we had made our kind of project, completed our project. I think so. Yeah, we have completed. We have gathered our data preprocessing. We have tested the model. We have evaluated it. Now it's time for save the model that will be ready for deployment. So let's do this now. for the deployment, we have a library called joblib. Okay, for joblib we have to import joblib. You don't have to install joblib. Okay, so what you can do, joblib dot dump, and then our model is lm, and what the thing is should be, what the name of the model should be is that Boston house price projection predictor. Okay, predictor dot pkl, pkl. Run this. Okay, we have our model here. So if you want to deploy it, you have to just only something like that, and model dot joblib dot load, and then it will load our Boston. We have Boston dot pkl. Okay, now run this, and we have a model. We can just provide the credential, and then we'll run it. Okay, so just the same thing that we have done. It is ready for deployment.pkl file, and we can deploy it wherever you can. Some of the deployments are Heroku, and then GitHub. On GitHub pages, etc. There are most freely available tool where you can deploy it, and you can show it to your friends also. So I think that you got intuition about how the machine learning workflow does, and we have gathered our data, that pre-process our data, train the data, test the data, evaluated the data, and I think that this is my very long video that I have done, because this is a project that I have to make. Now in the next video we'll be starting with the classification, and after the section of classification we'll be dealing with one more interesting project, which is the handwritten digit recognition or on an iris data set. Okay, so be sure to carry out with this series. So that's it for this video, and I hope that you had enjoyed this project and will show up to your friends. So thank you for seeing this video, and I hope that you will be carrying out with my next videos also. So bye bye.